Welcome everyone. My name is Ruwan Rajapakse. Today I'm going to discuss Sarvastivadi concepts of temporality and quantum mechanics, especially related to double slit experiment and quantum entanglement. Again, the topic is Sarvastivadi concepts of temporality and quantum mechanics, especially related to double slit experiment and quantum entanglement. So first, let's see who Sarvastivadi group is. After the Buddha Parinibbana or death of Buddha, Buddhist Sangha divided into 18 sects or 18 Nikayas, and one of them was Sarvastivadi, and they belong to the Theravada or Theravada group. And there was another group that came to Sri Lanka. It's called Vibhajyavadi. So, what are the concepts of Sarvastivadi and Vibhajyavadi, and how they relate to quantum mechanics? And I would be discussing two experiments in quantum mechanics. That would be double slit experiment and quantum entanglement. Now, the Sarvastivadi concepts and their ideas comes to us because we have the Abhidhamma books, and also detailed description of their ideas are given by Vasubandhu in his Abhidhamma Koshabaya. And there are a bunch of other books that related to Sarvastivadi in Yogacara books of various other authors. Then they were very prolific authors in that group. So they wrote a lot of books. So we have a lot of information of Sarvastivadi. So what did they believe? So they believed. First, let's look at our world that we live in. In our world, if certain phenomena happens in the past, that phenomena would affect present and also the future. For instance, if I have this marker here and if I drop it onto the table, and you could hear a noise, right? So the past event is dropping the marker, and the noise is the present, assuming it's the present. And the future could be somebody heard the noise and he was sleeping and he woke up. So that will be the future. So as per Vibhajyavadin, the phenomena from the past is gone, and phenomena in the future has not happened, or Dhamma, the word Dhamma. So what exists right now is the phenomena or the Dhamma of the present, and that's what Vibhajyavadin said. But Sarvastivadin said the Dhamma of the past, dropping the marker, and the sound that's the present, and somebody waking up due to the sound or the noise is the future. All these three phenomena exist at the same time, and that's what Sarvastivadi said. But Vibhajyavadi said no, the past is gone, those Dhamma is gone, disappeared. Future one, the person waking up, has not happened yet. Only Dhamma, only phenomena existing at this moment is the present Dhamma. So I just have this here just to give you an idea what Sarvastivadi believe. Dhamma or the phenomena, past, present, and future. And they said all these exist. Now, they didn't say this, but I want to make a change here. I'll give you an idea. So the information travel from past to present to future, right? That's what we see in the world. If someone um, yells at me in the past, if someone say, "Hey, how are you?" and then I reply, "Hi, I'm good," and that's the present. So the information from past to present is coming this way. And then in the future, he might say, "Well, I'm fine too." So information goes from past to present to future. Now we don't see in our life, day-to-day activities, information coming from future to present or information going from future to past. We don't see that in our day-to-day lives. So that's what Vibhajyavadin believe. But the Sarvastivadin says, even though we don't see it, these phenomena happens all the time. At present time, there's past and there's future, information from future to present, present to past, flowing. They didn't say that way, but I am just interpreting it that way. So as I said, for normal, regular day-to-day life that we live in, we see information going from past to present to future. That's what we see. Or information, we never see information from future to present or present to past. Information flow that way. That's fine. That's our world. But when you go to the quantum world of electrons, protons, quarks, leptons, mesons, etc., things are different. Past, present, and future all get muddied up. And that's what we are going to discuss and we are going to see. And these are not my ideas, by the way. That's ideas of present scientists. So let us first look at double slit experiment. We are going to look at two experiments: quantum entanglement and double slit experiment. So let us look at first the double slit experiment. So here I have two slits. It's like two holes, but it's slits. And there's a gun here, and someone is shooting these two slits, taking aim at the slits and shooting. So most of the times the bullet will go from this slit or this slit, and then you are going to see something like that here most of the time. But you could see some dots. Sometimes these bullets could ricochet and could hit here, or few bullets here and there. But generally this is what you're going to see. If you have two slits and hit, shoot bullets, that's what we are going to see. Fine. Now what happens if you send a waveform? Now let's look at what would happen if you send the waveform from two slits. So we are going to send the waveform. So one wave go from one slit, the other wave go from the other slit, and they get combined, and then you are going to see hills and valleys of a new waveform. Now I have a better picture here. Let me show that to you. Something like that. And here you have the top one is a one waveform and the second waveform. And if you see here, this is a hill, this is a hill, they get combined and become a combined waveform would have a bigger hill because they get added up. Similarly, if there's a valley, two valleys, this valley would be bigger. And then if a valley and a hill comes together, it cancels out. So you're going to get these two waveforms, one waveform, two waveform, and the third waveform. And third waveform is going to be a combination of the first two ones. Okay, so far fine. There's no issue. But this is the problem with the double slit experiment. So the electrons could, what would happen when you send electrons? So what happens when you send electrons is this. We are going to see you're going to see this one here. If you send electrons, they travel in a waveform. Electrons, photons, any fundamental particles, they travel in a waveform, and then they combine and create a new waveform, and then you are going to see new hills and new valleys, lines for new hills and new valleys. That's what we are going to see. But this is so far, no problem. We could say that the electrons, they travel in a waveform. Like birds. They, if you look at the sky and when birds go, they show a pattern. These electrons also traveling in a certain pattern. The bird would, make waves and go this way, that way. They all coordinate together and they create nice patterns in the sky. We have all have seen that. Same thing here. Electrons, they somehow communicate with each other and they create a waveform and they travel like that. Problem? There's no problem. But this is the problem. If you start sending these electrons one at a time, you send one electron, wait for 5 minutes or 1 year, doesn't matter how long you wait, and send another electron one at a time. And then what happens? Still you are getting this combined waveform, same exact waveform. Whether you send all the electrons together or you send one at a time, you still get the same exact combined waveform. How to explain that? This has not been explained. It's like, as I said, you have in the sky, you have birds flying, and they fly in a pattern. They move, they go like that. But what if we send one bird and then send another bird and wait for another 1 hour and send another bird, and then we draw their movements, their path? Are they going to be in that? If you combine all the paths, are they going to be in the same way that they would be flying as a group? No, because when they're flying as a group, they communicate with each other. But they know the one next to it move this way, so I'm going to move this way. The next one, the leader moved that way, so I'm going to move that way. They look at each other's movement and they adjust their movements. But if you send the birds one at a time, how would that bird know that the next bird, which path he's going to take? It's not going to be the same waves if you send, because no bird knows that what's the bird coming after going to do. But the electron seems to know. Even if you send one at a time, electron seems to know what future electron's going to do. It's going to be in that wave, even if it is only electron that is going through, and it adjusts to the waveform of the electrons that are going to be sent in the future. So there has to be some communication, information flowing from future to present. That's a one way of explaining this experiment. There are other ways of explaining this. One of the other ways is many world hypothesis by Hugh Everett, where these electrons would be, when you make a measurement, that each electron would create a new whole universe. And that hypothesis is out there. I mean, I don't know, it's been heavily favored, but it's still out there. So if we look at one interpretation, could be that these electrons, they know the future. They know that the future electrons, how they're going to behave. So accordingly they get into this form of the waveform that they're supposed to be even if the other electrons are not sent out yet. That's one interpretation. So there is information flow from future to present. And if there is information from future to present, then there has to be information flow from present to past, right? Because present becomes future and future becomes present and past, past is past. So there has to be information from present to past. So if future to present information is there, it's a logical conclusion. So this is one similarity between Sarvastivadi concept of temporality, or the Dhamma, that information transfer between all states, whether it's past, present, or future. And let's look at another second experiment that would be quantum entanglement. So what is quantum entanglement? So I have this here. So let's say we have two boxes, box 1 and box 2. And we take a pair of socks and we call pair 1, and we put the left leg sock on this box 1. So the pair 1 left leg, and the other one, pair 1 right leg. And then pair 2, we have the right leg on this box, and the pair 2 left leg in the other box. And then the pair 3, we have the right leg, and obviously pair 3 has the left leg. So let's say we pick one sock from this side. Let's say we pick 2R, pair 2 right leg. Then do we know what's in the other box? Yes, of course we know. It's a pair 2, it should be the left leg. It's known, immediately known. It's all predetermined. Fine. And if we pick by chance, let's say we pick pair 3 and it's right leg, no big deal. The other one should be pair 3 left leg. It's predetermined. When we put them together, the person, when they mix these socks, at that time, everything predetermined. No issue. But now we are looking at quantum spin up and spin down. In one box we have spin down electron, and the other one we have spin up electron. And then this box will be sent far away. Let's say one is in New York and the other one is in London, or they did the experiment, one on Earth and the other one far away in space in a satellite. So if we measure spin down here, the other one in the sky, in the outer space, should be spin up. The one on Earth is spin down. The other one is spin up. Immediately we would know that, because they are correlated, they are entangled. The word used is entangled. But this is the problem. Unlike in the socks case, these things are not predetermined. And Einstein said this is spooky action at a distance. What's happening here is, when we measure here spin down, it immediately, faster than light, send a signal to the other one, hey, I'm spin down, you become spin up. That's called spooky action at a distance by Einstein. He said that. But he said that in a sarcastically, saying that this cannot happen, so your theory of quantum mechanics has to be wrong. That's what he meant when he says spooky action at a distance. He was sarcastic. But it turned out to be true. There's a person named Ian Bell in 1960s proved that this is different than this. In the case of left socks and right sock, it's all predetermined. Here, until we make a measurement, this electron is in limbo. It doesn't know where it is. Once we make the measurement, it immediately pick whatever it is, it pick up, and then send the signal to the other one, hey, I'm up, you be down. That's the way it happens. It's been proven using the Bell experiment and many other experiments after that. It doesn't happen this way. It's not predetermined. The electron decide its spin when we make the measurement at that moment, and then immediately send the instantaneous signal, spooky action at a distance, to the other guy, other entangled electron. I am up, you be down. This is quantum mechanics, quantum weirdness. So now we look at what Sarvastivadi said. So now I interpret this way. Somehow these both of these get information from the future. There's information flow from the future. So it knows what's going to happen to it in the future somehow. So if I don't know how I'm going to die, if I know how I'm going to die, that such and such a place, such and such a thing going to happen. And that's exactly what this electron is doing. It knows that in the future somebody's going to make the measurement and then he's going to be down, and this one knows the same thing, so he's going to be up. So they know what's going to happen, and that's my interpretation, and interpretation of some people too. As I said, there are many, all interpretations are very weird. One interpretation, the many universe interpretation. So one electron goes to another universe, other electron goes to another universe. So every time you take these type of quantum measurements, the whole universe split. The wave function of the whole universe splits. That's a very weird interpretation. And so this quantum weirdness is something that has not been solved. So if you go back to the temporal or the time related explanation, he knows, this electron knows what's going to happen to it in the future. So he acts accordingly. He knows what's going to happen to him in the future. He acts accordingly. Information is going to travel. He knows that certain time it's going to be measured, and then he's going to be saying up or down, and he knows the same thing. So the information travels from future to present. That's another way of interpreting this. So those are the two experiments that I used to show the quantum weirdness, and information flow could happen from future to present and present to past. That's what the Sarvastivadins said in their theory in Abhidhamma Koshabhe and in their Abhidhamma Dhatu Skanda and etc. the Abhidhamma books. Now the question that I have not solved is, how did they come up with this idea that I've read up and down of the Sarvastivadi books, the Abhidhamma Koshabhe of Vasubandhu, etc. But I did not see any legitimate way that they came to this conclusion. They just made it up. Hard to believe that all these people, believe in something unless there is some way that they could justify it, and that justification is not available in their books unless I could not see it, and if you know that justification, please write down in the comment section. Thank you very much for listening. I hope you found this lecture interesting. Thanks again.